Okay, so from now on, what we needed to do to complete your project is now how you want to navigate on statistic roadmap based on the information you have. Okay, so as we talked about the first week of the semester, the part of the second week of the semester, as long as you have a three component, these three information, you know what test you can do. So first of all, you know what you want to do as a part of hypothesis. And the second thing you needed to know is how many variables you use for your hypothesis test. And the third component you need to decide in order to decide which statistic method you need to understand. And you need to really decide whether you're gonna use the nominal scale, inverse scale, or it's an ordinal scale, but you wanted to convert that as treat as inverse or nominal scale. That's what you need to decide. So that really is how to get to the the right places in a statistical roadmap. So as of what we talked about the Dylan's project earlier, when he decided to use an ordinary variable as a binary yes or no question. Okay, so in that case, you Dylan pushed this ordinary scale as a categorical and nominal variable. So made it both independent and dependent variables. See whether there's any association between the economic perception, people's economic perception, and how they open to or less open to the international or military intervention or things like that. Then we know that is a hypothesis. We use two variables, one independent, one dependent variable, and then both are categorical, yes or no, or yes, yeah, yes or no, right? That's what he used. So then it's a two variable, one nominal, one uh, also nominal independent, nominal dependent variable. So it ended up with a chi-square test. But as what we discussed earlier, if he decided to use this ordinary variable as a numeric variable, so convert this ordinary variable as more of an interval variable, interval variable. So recording like a zero, I mean one or zero as little, maybe two some, three as a great deal. If you do that, you treat that those variables interval variable. You have two variables, and what you need to look at is just a relationship between these two interval variables. So it's gonna be correlations if you don't care about causal relationship, but if you care about causal relationship, that's a regression model. And then even you decide that Dylan's case, if dependent variable, I want to just stick with a yes or no, but I wanted to use my independent variables as interval variable. What is that? Okay, so as that is the purpose of this the last former lecture before our lab session moves on with your project lab session, this the full lecture section. I wanted to go over beyond what our textbook really covered, but some alternative way to run some analysis. So for example, logistic regression model, okay, that's not our theory book, but just some portion of examples and explanation is our SPSS handbook. But in many social science and political science research question, we ended up with the dichotomous answers like a yes and no, yes, I voted or not. A lot of dichotomous yes or no kind of a question. Then you recode those coding system as a 0 and 1 and use as more of those ratio, odd of a ratio. That's about logistic regression model that I will go over today. All right. So if Leland decide, okay, I'm gonna stay with the independent, another independent variable, but nominal dependent variable, then it's a logistic regression model. So it's very important for you to decide what kind of scales of measurement you use for each variable, especially it is originally coded as an ordinal variable. You need to decide, are you going to treat that as a nominal or are you going to treat it as an integer? If you treat it as a nominal variable, you don't care. You don't need to think about how one is coded or what is two is coded, because you just look at the statistical software. We'll just look at, they're just different things. But if you decided to use as integer scale, if you use them as a part of statistical analysis, the statistical analysis will look at the value of one and two and three as different degrees. So you should be more careful about how you code them. So if you treat them ordinary variable as interval variable, just be more cautious how you code them. Okay. So that's the strategies we're gonna use for next 2.5 weeks based on your hypothesis and number of variables, how those variables are coded as integer, ordinary, and nominal. That's based on that information, we decide which test you're gonna run, and we actually gonna run. And then I want to make sure that what numbers you need to report to discuss the statistical significance. And for further informative information, whether you need to provide this percentage or mean values. So that's what you're gonna spend for the rest of the semester. Yeah, really, rest of the semester. Okay, is that all clear? Any question? Okay. So from now on, okay, this is not what we expected to cover for this specific course. This is beyond the expectation for this course. But as a more motivated teacher, as a more motivated students like you, somehow, like if we end by the end of a textbook, like Dylan's question, if he decided to use, okay, my independent variables are integer variable. What if my dependent variable is categorical? Then we don't have option. But by having logistic regression model, if we cover this, you have at least one option. One, the best analysis you can do, whichever, whatsoever the scale of measurement you choose. There's always at least one statistical analysis that you can run. So that is my purpose. And just to give you some sort of the general idea, uh, political science academic work, right? About 70 to 80% of academic work done in political science, it's quantitative, okay? So out of those quantitative research done in political science discipline, and uh, about again the 70% of the quantitative research, they use different variants statistics of a regression model. Okay, so what it covered for the last 2 weeks and 2.5 weeks, it is about the simple regression model when we have one independent variable. And then when we have a multiple independent variable, it's a multiple regression. Okay, but as the situation, most of my independent variables are integer, but my dependent variable is whether I voted or not, whether I support it or not. Okay, what are you gonna do? Let's say with this kind of hypothesis with the given scale of measurement. So then we use the logistic regression model. So this is the situation that, okay, your hypothesis is similar and number of variables are the same, but you ended up with independent variables, all integer. Okay, and your dependent variable is binary, yes or no, categorical. Okay. But if your independent variables are also all categorical, then it's a chi-square. If you have independent, nominal independent variable, but your dependent variable is integer, that's either it's going to be t-test or f-test, ANOVA test, ANOVA test family. Okay. So depending on scale of measurement, it just kind of just move around. Which test might be less and more appropriate. So in this case, logistic regression model, you ended up with yes or no and voted or not kind of a situation with the most of your independent variable, they are interval. There are, but in that case, you should understand it's a still part of a regression model, and regression is the foundations of statistics. So what you can do, what you should do before you start with the logistic model, your dependent variable should be binary categorical. And then you should code them as a 0 versus 1, because the dependent variable in terms of the interpretation we use as more of a ratio. So ratio goes from 0 to 1, right? So that's the concept they sort of infuse into logistic regression model. So before you go ahead and start with the logistic regression model, your dependent variable, they should be binary, and also it should be coded as 1 and 0. Okay, 0 should be usually no, did not vote and didn't do it, and 1 is yes, and I did, or maybe supported. So that intuitively make more sense. I do not want to go over, the theoretical foundation of how the numerically it works. It's just like a chi-square test. Okay, how what we calculate just a chi-square test, but we call that as the name of the statistical test. It's a world test. You run chi if you put it the variables and run a logistic regression model, they will provide you world statistic, value and p-value. So most important thing in this variant test, we actually do not use the raw slope, raw regression model, just like a simple regression, multiple regression model. Instead, we actually applied log the function to make yes or no. Yes here and no here, but we just try to connect some sort of curve at odds with the log the function. So, mathematically, log the function give you more of the natural curve function, right? And then for the interpretation, the measures, we actually use exponential value of slope from the log odd function. So I know it's more mathematical term, but what I want you to understand is that if it is just a regular equation model, to the raw y variable, you put the log the function. So it's like when we have a yes or no, it just straight drop from no to yes, just straight drop. There is nothing else. But since it's a regression model and your independent variables are still continuous in other variable, so what about it just, although it's just kind of a steep, just give some sort of a curve, log the value. So when you say, oh, so once we get to certain point, it is more likely to say yes. At certain point, it's less likely to say yes, or it's more likely to be voted or not to vote. So log the function, we sort of give more of a natural curve. We use that as a ratio, other ratio for the functionality uh, of the logistic regression model. So it is more of the mathematical manipulation. If you put the raw equation model, we apply the log function to make more of a curvy line. It's not never straight line because it's yes or no. That's your dependent variable. So then we also looked at the actual slope, log the slope, you make exponential slope. That's the how you're gonna make interpretation. Okay, so for example, when you make exponential value of 0.246, and that value is 1.278. So now let's focus on interpretation. Okay, so when your exponential slope, value of slope, which we call that as odds ratio, if this value is larger than 1, Okay, that means it's a possible relationship between your independent variable and dependent variable. If for that odd ratio exponential slope that is a zero, it's flat, so that means there's no relationship at all. If the exponential value is less than one, that is a negative relationship. Okay, so since it's only yes or no kind of dependent variable, we wanted to make sure there's a way you can provide some informative information. So let's say this is a logged odd slope, and this is like a really baseline. So the log odd, the slope is 0.246. And if you make as exponential slope value, it is 1.278. So let's say this is actually, I don't know whether you remember from the last past class session. This is actually the number I plug in to logistic regression model. What about if you have the additional years of education? What about the probability of or odds probability of voting versus not voting? Okay, so how you can actually use this information? You can use as how many times, or you can just use this odd ratio, subtract one and multiply by 100, make it the percentage, and you can use it as a percentage. So how I can interpret this? Okay, just listen to me. Okay, ask me again if it's not clear. So this information, it is over one. So more education, people are more likely to vote. It's a possible relationship. That's what you can confirm from the odd ratio value of over one. And then this specific number, you can use that. So people have one additional years of education. They are 1.27 more likely to vote. Okay, the odd of voting is 1.27 times more likely. Okay, or you can use the percentage. Okay, subtracting one, just throw away that, and then 1.27. I'm sorry. So 27%. That's the information you can use. So if you have one additional years of education, people's probability for voting increased by point out of the probability increased by 27% or 0.27, okay, on the ratio. That's how you can use this odd ratio for interpretation. And at the end of logistic regression model, okay, again, we don't have this in our main textbook, theoretical textbook, but since it is in the handbook, SPSS handbook, at least I want you guys understand what they are talking about. And then R square value is not really the R square value we talked about, coefficient of the multiple determination, but it is actually the logged function is R values are really kind of pressed to make some curved line. So the specific R square value you can use for logistic regression models, Cox and Snell R square value. The same thing for interpretation. How much this R square value represent is how much your independent variables explain the choice of voting or selection of yes or no. So how much they explain the probability for the action you make for your dependent variable. So those are the information you can report for your interpretation. So for example, Dylan's case, this is definitely one option. If you decide with the current binary, you already code it as 0, 1, okay? So as it depends the variable, but if you convert that binary to more inverse variable, make as inverse variables, and then it should be a logistic regression model, okay? So just think about some benefits of having this statistical model and with this interpretation versus the chi-square test and regression model. Again, it doesn't mean that you can run any test. No, that three conditions, the three components should meet. How many variable? What is your hypothesis? And then what scales of measurement do you have? If it is not fitting and your those tests are not right tests for you to run. Okay, so this is a logistic regression model. Any question up to this point? All right. So my next is, okay, again, it's not part of, but actually our theory book mentioned that briefly. But I want to teach you the practical part of the dummy variable regression model. Let's think about the real world statistics. When we predict the people's, political attitude, and when we use the feeling thermometers as the dependent variable. Let's say most of our independent variables are in over scale. Okay, it's a numeric. Then it's a multiple regression model. But think about it. As a here's one of the variables, like race, ethnicity, or partisanship, Republican versus Democrat and versus independent. They are categorical variable. They are not numerical variable. They are not in our variable. Then the basic model for the regression, it should be both, goes back to the, statistical roadmap. All your independent variables should be in our scale. But just most of your independent variables are interval, but one or two independent variables, you want to combine them together and run them together. They are categorical. They are nominal variable. What are we gonna do? We use regression model with a dummy variable. Okay, how you can make it happen? So since it's a regression model, they still looking at some linear regression line. So instead, you just kind of, having like, kind of a different like a curve in here and there. Actually, we have a different regression line for white versus black versus or Republican versus and Democrat. So different regression line for different categories of the group. So that's regression model with the dummy variable. So in order to do that, your cleanup stage for the variable, what you're gonna do is that. So again, party ID is maybe the example. You have a Democrat, Republican, and Independent, and a regression model they do not recognize there as the separate group or different group. Instead, they think it's numerically related. So that's not what we want to measure. So you make out of a party ID group, you make a separate regression line, separate variable for each group. So for example, you code Democrat as one and rest of the categories as a zero. So we code them and you make it, this is a variable for Democrat. And then you want me to include another variable for only Republican. Then you need to recode the rest of the partisan group as a zero and Republican as a one. And then in the regression model, you're gonna include all your interval independent variable and now include your recoded Democrat variable and include your Republican group. So when you plug in here now, Democrat 0, but Republican is 1, this regression model is the regression line model for Republican. If you put 0 for the Republican variable, but you put 1 and dependent, independent variable for Democrat group, this is a regression line for Democrat. Okay, so this is how you can run regression model with a dummy variable in case you have very just one or two categorical variable you still wanted to include in a regular regression model. That's what we can use for the purpose of the research. Okay, so the beauty of this regression model with the dummy variable, we can still save some of those analysis with selective and limited categorical variable for the regression model. And social science research, you cannot really ignore or escape from, the mixture of interval and nominal variables. So this is the way. All right. So as time allows and how much as you want it to go, my plan is on Thursday class, I will show you how actually you recode and then run this different variant of a regression model, and then how you can interpret it. So that's what we'll cover at least first half of the class on Thursday class. All right. Before we totally move on for your project. Okay. So there is a way. And and then this is another version of, well, I'm just going over this many different versions of like a variant of a regression model. As I mentioned that you will see, the statistical quantitative, research paper, research done out there, and they done with the regression model, and more than 70-80% of the study. Okay, regression model somehow it include, and they are more control power. There is a beauty having the equation model. Then they can escape some of the issues with the nominal scale of a variable is a part of that. And what if I ended up with some of this circumstance? It doesn't really fit in with the conventional regression model. So this is the reason out of those 70, at least 30-40% of the regression model is this variant versions of the regression model. So for your own learning purpose, I'm going with that beyond the textbook. Okay, but just let me go over two more. It's just simple enough, but I will share more about academic controversy and debates about that. It's a standardized regression coefficient. I'm not a big fan of this standardized regression coefficient. Do you remember when we went over correlation model? It is a standardized slope. Okay, this is a standardized slope. To the rho slope, you multiply by the ratio of the standard deviation of two variables. So once you make the rho slope to standardized slope, you can compare them. Okay, when we talk about regression model, the each slope is just based on the unit of analysis. It's not standardized slope. It can be the downside of the slope, but the beauty of that slope in regression models, you can use that unit for more intuitive uh, interpretation and result to say as one unit increases, what's going to happen your dependent variable. So that is some of informative information you can get out of a regression model. But some people, they think, is there any way we can really point out across maybe 5 independent variables? Which independent variable is more important than the other variable or over the other on your dependent variable? So some hypothesis, so it goes back to your hypothesis, one of a component, how you're going to select your statistical analysis. So your purpose of the research is that among age, education, level of the socioeconomic status. And out of all this, what are more important matters for the voting choice or policy issues and policy approval, issues? Then you actually force the slope for each of those independent variables standardized. So instead of using rho slope, you use a standardized slope. Okay, so just to pressure them to be the range of like -1 to +1. Okay, so now you can compare. Oh, ACE is more. ACE's slope, the standardized slope, has a larger value than socioeconomic status. So that means the age is more important than status, I mean, the economic status. So for your voting choice, or I mean, maybe your policy attitude, because it's a regression. So some statisticians, they are willing to do that, but my hesitance to there is, think about it. Age is 1 year of the additional age. And then let's say the scale goes from 18 to maybe 100. But socioeconomic status, maybe scale wise, or maybe you can use income. It can go to from $0 to maybe in infinite number of the income. Some people, their income is not even countable, right? So how we can really, you know, just theoretically make the age and income comparable with that kind of the unit, right? But it's a kind of a forced, standardized value. We try to standardize the coefficient and slope. We try to measure which coefficient is more and less important. Okay, some statisticians they're willing to use, and but they use as a z any standard. I mean, as any equation model, if you read the academic journal article, had z value in front of each independent variable, you can consider that is, oh, that is a standardized coefficient, standardized slope. So maybe the purpose of a study is to find which independent variable is more or less important on your dependent variable. So sometimes they do that, but I just, unless it's necessary, I just think the age is age. Socioeconomic status is the way it should be. And income, you cannot really convert this a year with any like a monetary value, right? So for that reason, I'm not a big fan of the standardized slope equation model, but you can do that, all right? Nobody really say, no, I decline your work because it's a standardized slope. Nobody will say it's still acceptable. Um, uh, the variant of the regression model. The last thing is just a simple mathematical manipulation. Um, when you have interaction, theoretically, your hypothesis asked that. Okay, um, actually, it's a real world question, and people believe that this is more of the target of some of the government administration. Higher education make people more liberal. Okay, and what about the income level? Okay. So they are proven that it is a statistically significant value. If we come from also with the real world data set, we tested like last week, right? If you have more education, you're more likely to be liberal. We confirm that through the national data set. But what if it is combined with the income, right? So more income and more education, actually it changes the dynamics. So if it is the research question, your hypothesis you wanted to measure, you wanted to have, what about those interaction terms? It matters. We talked about multi-factor ANOVA. If they are categorical, independent variable, if you want to see cross interaction, that's multi-factor ANOVA. But if it is your regression model, and all your independent variables are here, interaction wise, it's inverse scale, then you use interaction term by multiplying. So multiply, so income and education as a separate variable, and third independent variable is multiplying uh, interaction term you include as the part of a equation model. So that's interaction that you can see whether this slope is still statistically significant. Then sometimes, but the important thing you need to understand is sometimes interaction, by adding the interaction into your equation model, sometimes it make your main independent variable insignificant. Sometimes it is your controlling those interaction independent variable between your independent variables make insignificant independence, sole independent variables effect more significant. So you may want to play having interaction term in it, or pull it out and see some of the dynamics of the changes in significance. Okay, so by doing it, sometimes you can produce a beautiful equation model, and sometimes you may just leave it out, may kill all those significance as well as independent, as like this situation, as in interaction term itself is also insignificant. So that's some of the things you need to consider theoretically. So these are what I prepare for you to beyond the textbook, beyond what you plan to cover for this week. So you have all sort of option, regardless of your decision, whether it's inner, ordinary, and nominal scalable measurement. You have at least one option to run your test based on your hypothesis. So I cover them. But up to this point, is there any question regarding what you covered? Okay, so at least there is some point that they talked about here and there in our theory book, especially the logistic regression book is not there, but it's in the handbook of SPSS handbook. So if you wanted to have additional information, you can read and ask me a question later. Okay, so otherwise, you can review what I comment on your variable cleaning session before we move on Thursday class. What we really do for your domain analysis for your project. So I will end the class today here.